it to the cloud. Share screen, share. Not that. Here we go. So we're going to start with the study guide today because going through this will help you with what we're implementing in the lab. So to start us off, templates. What is a template and why do we use them? So like I said, a template allows you to create a data structure that has an unknown type. So if we go, we had this last time, we were creating this stuff. I might actually just leave all of that, not gonna lie. Yeah. Shrink that, actually all the way down. So if we wanted to make it a template, and I need to get rid of that to do it. Yeah, let's just delete. There we go. Oh crap, I got rid of the wrong one. Oh fuck. Whatever. I'll just make a new one. This is fine. This is fine. Sure, here we go. So you make your class just like you normally would, and I had the one all set up, but now I don't. And you put template, type, name, T. And actually this T right here can be whatever you want it to be. I think about it like a variable name, but it's the variable name of the data type. So that's a little weird, but you'll see here. If we do like T there, now, so right here we got T as the data type of this variable. And so when we make a Steam object, so we have hashtag include Steam there. When we make a Steam object, it doesn't like that. Well, let me see if it. It's not liking that. Public. There we go. Maybe. I'm doing something wrong. I usually don't hit a hiccup where I'm doing something wrong right at the beginning. No, that's not important. Template, you can do type name or class. Maybe I'll try it. Yeah, that's not the issue. Well, fuck me. Give me a second here. Give me a second. I don't think I'm doing anything wrong. But, you know, none of us think we're doing anything wrong. Template, private, public, ABS, yeah, T, this looks fine. Okay, let me just keep working in this and I'll fuck around with actually using it later. Okay, so you've got this T thing here, and you'd make that kind of like if we included hashtag include vector. So when you make a vector, you do a vector, and then you put some sort of data type there, and then you call that your like storage or something. you're storing ints in there. So this is how, like, theoretically, I should be able to do Steam. And then in here, it would create a Steam object. I don't think that's the issue. Yeah, that's not fixing it. I'll worry about it later, Gabby. But thank you. If you have any ideas, feel free to send them. I'll try them, but I'll cover that later. But so theoretically, when we do this, it takes the int value and replaces the t with that. So now var is a t value. So what is a template and why do we use them? This is a template right here. And we use them so that we can have data types that store different types of information. And so especially for storage data types, anything that's specifically used to store information, not manipulate it in any way, we don't want to have to manually write a new version of that data type every time we want to store a different type of information. And so this works perfectly for that. How do you declare template class? Just like this up here. So obviously I'm doing something wrong. But yeah, like, so right here, this shows like a good example and that's matching what I did here. Template class, so you can do class or type name, though I think you should just stick with class. There's a minute difference in the back end of C++, but they added it to make it more consistent with other languages. And then, so yeah, right there, just template T above it. And the way you can think about this template class T, because there's a couple ways we can use this, but anytime you see template class T, go to the first squiggly bracket that it's above. So in this case, this is attached to this squiggly bracket, and then go to the end of it. Because if you wanted to write other functions or class member functions outside of the class definition, so if you wanted to write like, oh, like right here, you wanted to write Steam right here, but then you need to define it somewhere, like down here. You would have to do Steam : Steam. And then also it's mad at you because it's a template class, so you need to do template type name T. And I did that wrong. I'm just fucking up templates today, guys. Argument list for class. Oh, because it's T. There you go. Actually, I think he talks about like all of this in here, maybe. No, he doesn't. Maybe it's for the lab or something, for the project. Yeah, whatever. Okay. So yeah. So if you wanted, so in this project, I personally like if you really like the .h and .cpp separation, then you can do the class definition there and then the class, the class definition there and then the function definitions outside the class like this. But for templates, all of the class information, all of it has to be contained into one file. So there won't be a separate .h and .cpp file. So like if you like .hcpp separation, you can do the class definition here and then all the function definitions outside of it. Or you can skip that and just do all of the function definitions inside the class definition. So if you wanted to, you could skip that and just write it in here. That's a personal choice. You're going to have to decide which one you want to do. There's no points taken off either way you do it, but you have to pick one because they have to all go in the H file. You'll even notice in Zybooks, in this lab, there is no CPP file for the H file we give you because you can't have that. Templates have to all be defined within their, like a class that's a template class has to all be defined within one file. And that has to do every time you make a new data structure. So a new type for your data structure, it actually compiles another version of your class. And so that unique property requires all of it being in one class as you write it. So I know that's weird, but you just have to do it that way. But yeah, just going to show you inside of the lab, stacks and queues. Down here, you only have the abs.h. Oh, we also have these leaker.h and leaker.cbp files. So anytime in this class that we have you submit stuff to Zybooks and there's dynamic memory involved, so you're allocating stuff to the heap, we use this leaker.h and leaker.cpp to keep track of any memory leaks you have, and your code will throw an error at the end and output some extra stuff that'll not give you any points if you have any leaks. So even though this is a small, relatively small project, and leaks won't be that big of an issue, they're big enough that any size leak you have will trigger these files, and so you won't get points. So this all talks about the use of leaker.h and leaker.cpp since it's the first time you've seen it. Okay, so so yeah, how do you declare a class template like this? And like I said, it all has to be in one file. So if you want to do it outside, if you want like the .h and the .cpp separation, you just have to have a separate thing like this for each of your functions. Because like I said, you take this, you go to the first squiggly bracket, and you go till it ends. How do you declare a template function? It's like, oh, so this is outside of classes in general. Like we could declare a template function in here by itself. If we did the same like template class T, and then we started to write a function, let's say like void foo. In here, you could take in template types. So you could say like T var1, T var2, and then like, let's say this returns T. And instead of foo, let's just call it add, because that's what we're going to do. We're going to return T plus T. So just like that, we're creating a template function. So we've got T everywhere because it's just adding and stuff, but this can be used a lot less aggressively by doing other things with T. You're having like maybe only one variable is T, but still this allows you to create a function that uses templates and does the same exact thing for all of them. Now, if in this case, if the variable you create this a template function as does not have addition, it'll throw an error. So like what doesn't have addition? Most things have addition. No primitive vectors maybe? So if we did add a vector int vector int. If we did that, would that throw an error maybe? I don't think you can add vectors together. Yeah, see, that's a no-no. But it should work if we did like 1 and 2. Oh, no, illegal use of this type as an expression. What? Okay. I am just having a great time today, guys. I promise you I know how to use templates. Here, actually, let's just go to here. And I'm just going to steal one of theirs to make sure I can even see if it works or not. And see what I'm doing wrong. Okay, so they use class, so that shouldn't be an issue. T result, yeah, that's fine. T result, and they called it get max. I'm only a little confused. Is it just because I did type name? That shouldn't be an issue there. Yeah, no, that was fine. So what if I called this add and instead I did A plus B, add and then is it because I did that? Is this not exactly what I did? I did var1 and var2. Is it because of that? What? I'm so confused. Whatever. Okay, sure. It works. There you go. Still, this is how you declare a template function. Don't know why it was mad at mine, but it's okay. Oh, wait, mine was the other one. Hold on, let's go to the other one. Let's just make sure this. Oh, I did T plus, I'm an idiot. There we go. Oh my God, I'm so good at programming. I hate everything. Okay, there we go. Now it works. And then if we did vector int, I'm having a morning, y'all. I'm having a morning. Now it would be bad because they don't have an addition operator. Yeah, see right there. So that's what I was trying to show you before. Does not exist for this option. So T can be any type, but if you do something in here that T can't do, it'll give you an error right there. But int would be totally fine in that case. And when you're dealing with storage data structures, you're never doing like addition between, like you're never manipulating the data type, so that's never going to pop up. You're just creating like arrays of it and moving it around. Okay. So I know I was just shit all over the place in explaining that, and we actually never got this to work, did we? So I'm gonna try to get this to work in a second. But does anyone have any questions besides like how to get that to work? Oh my God, Gabby, you said that. Oh my God, Gabby, you're a genius. I don't know why the thing didn't pop up for me. Okay, can you overload the add function to make a function that'll eventually work for adding vectors? I mean, you could make, you could make one that's like vector int add. It takes in vector int var1 vector int var2. And then here you could add them together. Okay, this would be fine. And then return, is there a way to like combine vectors var1 dot? It'd be like a for loop. And so you can do that, and that should be fine. Yeah, now that works. And I wonder actually if you can do template type name T T T. That works too. So that's pretty cool. Okay. So yeah, you can overload your own template function that you make. Yes. Cool. Like I said, I'll work on this, and actually, you know what I'll probably do? Just make add new project. Empty template. Create. Add new item. Steam.h. Add new item. Main.cpp. If this doesn't work, I'm just going to move on because it definitely is like how you do it. Here we go. Int main. And then hashtag includes Steam. There it is. I don't know what the fuck. There it is. Perfect. Okay. Can you overload a function, make a function that'll eventually, yeah, so yeah, okay. And then I was thinking about in terms of Java, but if the parameters are different, then that makes sense. Okay. Yeah. So with templates and stuff, if you have a function, let's set this to, though we were working in this one already. If you have a function that's more explicit than the other one, it'll take the more explicit one. So in this case, this is way less explicit than this. I don't know what the actual rules for that are, but there you go. Okay, cool. So that's templates. Definitely gonna be using that. Template, if you wanna make like a template pointer, just a quick little show. You don't like the you don't, I guess you could still make. So like in here, no, in here. I'm gonna close that so it yells at me. Cancel. In here, if you wanted to make a pointer, if you wanted to make a pointer here in your class, you wouldn't do T and then make this be a pointer. You could do that, but that would mean that this has to be a pointer in order to use this as a pointer. But so with dynamic members, you need a pointer to the array. So you just make T pointer there. So now you can just have int there. And so it's storing int. But this is now a pointer and can point to stuff on the heap. So you'll be doing stuff like this. Okay. Operator overloading. Oh, my leg is tingling. What is operator overloading? So you actually kind of already seen it. You've seen it in the assignment operator. That's the assignment operator overloader. So when you did stuff like in here, did Steam reference operator equals Steam reference to copy or something like that. I think it looked like that. Something like that. So this is an operator overloader. We'll define it later. This is an operator overloader for the assignment operator. You can overload any operator. So let's look. C++ operators. So is there a list here? Okay, so the arithmetic operators, compound assignment operators, compare it, relational comparison operators, sure, logical operators. So all of these operators, you can define what they do for your class by going in here and writing whatever you want the return, because it can return whatever you want. With assignment operator, we just have you return an object itself. But here, you can return, but like any other case, you can turn, even an assignment operator, technically you could return whatever the hell you want. I think that might not be true because it doesn't need to take the left and the right with this subject and the who. No, you can have it return whatever the fuck you want. Yeah, because the return, yeah, okay. You could, I haven't tested it. We can test it later. But for most other operators, you can do like int and then operator, and let's do the and operator. And it takes in and then from here, now this operator returns an int for Steam. So if I go here, and it says Steam int var2 and then var1. Love me some great variable names. I do. var1 and var2. And then int num equals. So look at that. In this case, this is valid. I think if I had put a char there, it wouldn't work, right? Yes, no, fuck, it shouldn't like that, but it is. So let's do a different, oh, come on. Let's do a different operator, see if that's just a weird one, because that's with references and stuff too. What if I made this a string? And then there's a finally man hashtag. I need it to be bad at me. I'm trying to show it being mad. There we go. Now we're good. Okay, so now it's mad at me because I'm trying to assign a string, an integer value to a string. If I made this an int, then it would be fine. So you can have it return whatever you want. Decide the operator you want it to deal with. But now here you are defining the behavior of the OR operator. So you could do whatever the hell you want to in here. You could just have it always return 2 if you wanted to. Like, that's totally legal. Okay, so I don't think I actually answered any question about operator. So yeah, what is operator overloading? It is defining the behavior of an operator for your class. So all classes that you've seen, like strings and stuff, they have their own operator overloaders because they needed to define what addition, subtraction, I don't think there's subtraction for strings, but they needed to define what addition does. I wonder if we could even hop in there to look. So yeah, right here, look at that. So this is the string class, and it's got all of these operator overloaders. And so for the comparison operators, it returns a bool. Bool. Is there any other type of operators I got? Shifting operator, so it shifts stuff. But yeah, either way, it's just showing you like it returns something, it defines the new stuff for this operator. But every class does that. So you can do that for your own inside of here using the operator word and then whatever operator you're overloading. How do we overload an operator? So just like, how do you write it? Just like this, give it a return type, tell it what operator to use, and then pass in the data type that you're working with. So like here, strings are const character arrays. Strings and character arrays can be back and forth. But in this case, we pass in a copy of a reference to a Steam object. And actually, you could not have this, so we could do like, we can define it for like int var or something like that. And then now here, this is wrong because this needs to be an integer. And this still needs to be assigned to an int. There you go. So it doesn't have to be a reference to an object. You can have it be something else like this. So it's var1 or 1. And you can define that to be whatever the hell you want that to be. Okay. Why would you overload operators for your classes? Because you want it to do something specific. So like a good example, in my opinion, is strings and the addition operator. The addition operator, you could think about like without defining it, it could maybe add each of the characters between two strings together. Or it could, if you did a string plus an integer, instead of adding the integer to the string, it could add the integer to the ASCII value of the first character or something like that. That's just undefined behavior that you might want it to be implemented one way or another, but C++ doesn't know what the fuck you want to do with it. So writing your own overloaders for operators allows you to define the behavior to be exactly what you want it to be, so that when people use your class with whatever operators you have, it does something specific. Okay, so that's operator overloading. Any examples y'all want me to look at? Because it's really templates and operator overloading. There's just a lot there. Like there's a lot that you can do with it, like a bajillion examples. So if you want me to go over something specific, like how, like what use case something has, or like what happens if you do something specific, we can try it out. Like just how Gabby asked, like, could you overload a template function, stuff like that. Okay, cool. Last but not least, with the study guide, data structures. So right now, the two data structures you have to work with are stacks and queues. Let me get out. And actually, I think he talks about it in the lab doc. Oh no, I don't have that wire. Oh, that's very sad. I don't really get to use this very much. Whatever. We could just draw it out with my mouse. So here, new share, a whiteboard, sure. So you got stacks and you got queues. Draw. It's gonna be beautiful. I'm not gonna try to write text. But so a stack, you can think of like a deck of cards, or maybe that like ring game. Oh, that ring game is perfect actually. Where you have like the peg and it's got like a flat bottom, and you've got these little rings that you're trying to like put around. So you got like an orange ring, and then a green. Colors are arbitrary. And then a blue. And so you have to like move all of them in the right order onto this new peg, and they have to go orange, green. I think you need 3. Rigged carnival game. God, no, not the throwy one. Not the throwy one. The one where it's like stacked. There's a. Hold on. There's like a ring on stack, 3 pegs, right order puzzle. Tower of Hanoi. There it is. Tower of Hanoi. Flash isn't a concept anymore, people. Oh, that's so sad. Flash isn't a thing. Oh, wait, does this work? Tower of Hanoi. This is definitely not sketchy. Okay, so it's this thing where like you're moving it between them. And I can't take the blue one. I have to take this one on the top. I don't know if you can hear shit. This is annoying. So you have to take the one on the top. I wonder if I can make this hard. like a hard mode. Whatever. Still, oh, it's level 1. Okay, so the point still stands of you can only take stuff off the top. And I don't know the correct way to do this goddamn puzzle, so I'm not even gonna try. Oh, now I'm trying. Why do I hate everything? Beautiful, I'm so good. Anyways, you get the idea. If you can only take stuff off the top. That's how stacks work. You can only take stuff off the top. You can only put stuff on the top. So, whiteboard. Where's my whiteboard? So with this beautiful example, I'm gonna erase it. You can also think about it as like a container. And as you put stuff on the bottom, as you keep putting stuff in there, you can't access what you put below. You can only access the top. So you put stuff on the top and you can take stuff out of the top. And so I have to go one by one down. That's how stacks work. So vectors actually kind of have stack implementation already in them. So if we open up a vector, vector, so if we do var1 dot push back, and then one, and then var1 dot pop, so pushing back adds it to the end of the array, and then pop back takes off the back of the array. So if we use the two of these combined with like a for loop or something, you can see, oh, now I gotta do it because I said it, fuck me, whatever. Int I equals 0, I is less than 10, let's plus I. var1 dot at I. You can only see the whiteboard. Oh, Lord have mercy. I'm writing things. Thank you. See out. var1 dot at I. Oh wait, no, I want to see out this. See out that. There we go. Pop is a void? What? That's rude. The one you're making is not going to be void. At var1 dot length size -1. Okay, that's horrid, but there we go. And here I'll do var1 dot size -1 there. I broke something. Okay, well, anyways, you can see it here. We add it in the order of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it pushes back 9, and then it prints out 8 through 0. And so it's taking off of the top and placing on the top. So just that concept is the stack. I spent way longer on that than I needed to. What term do we use for adding and removing elements from the stack? We use first in, last out. So the first thing that you put into the stack is the last thing that's going to come out. You can see it here. The first thing we put in 0, the last thing that came out was 0. what is a queue and how does it work? A queue is kind of the opposite, but it's not if you flip both of them. So if you do so a stack is first in, last out. If you flip both of them and say last in, first out, that's wrong. So it's like a double negative. It'd be like saying I'm an apple and then saying I'm not an apple. Both of them are saying you're an apple. So both last in, first out is the same thing as first in, last out. A queue is first in, first out. You can think like, I think a British way to say a queue, to say a line is with the word queue. And so it's easily represented as a line. So you should be seeing the whiteboard now. So if you got people, it's like, I'm going to get in line. And then another person's like, I'm in line as well. And then there's a line, and then there's a line. And it's a whole dot of crazy people getting in line. And the line works sort of like this. Just a bunch of Brits, exactly. All these British people in a queue. You wouldn't take the last person that got into the line out first. So you wouldn't be like, oh, we're going to remove from this end. No. The way it would work, to be fair, so add those people back in. They didn't get removed yet. This first person that's been standing here for so long, they get removed, and it just goes around like that. I removed that in the wrong order, the last one, that's fine. So the way that's represented, so vectors, again, have this implementation just because it's a very common implementation. And I should be sharing my actual screen. So here, pushback is still the right answer, but now we don't do pop back. We do DQ. Is that in place? No, it's not in place. var1.d. Is it pop front? Is it just front? Vector C++. There's some function for it. Like Dairy Queen, exactly. Size, empty, operator, front, back, assign, pushback, popback, insert, construct, in place, pushback, popback, insert, erase, swap, clear. Huh, I guess it doesn't have one for that. Whack. Okay, well, technically, actually, we could just implement. There we go, and then var1.d push pop. There we go. So Vector doesn't have it, but this is showing you the built-in queue functionality inside of, front. There we go. This is the built-in queue functionality inside C++. Run it. Yeah, shush. So here we start by putting 0 in, and it has 0 first, and we always keep printing out the front value, so it gets rid of 0, and now the front's 1, and the front's 2, 3, 4, all the way to 9. So normally the terminology for a stack is push and pop. So like you push it onto the stack and then pop it off the stack. And then for queue, the terminology, and I've never seen push and pop for it, but sure. The terminology is NQ and DQ. I don't know why it isn't for this. But yeah. So like, what is a queue? How does it work? You put the first thing you put in it's chilling out in the line, and it's going to be the first thing that goes because it's been waiting there the longest. Stack isn't that way because you only have access to the top stuff, so the last thing you put in is the first thing you have access to, and the first thing you put in is way at the bottom, you can't see it yet. Okay, and then what is the terms we use for adding and removing elements in a queue? Oh, this is the term, so yeah, the term for a stack, so this is like the term, is push and pop. The term for adding and removing elements in a queue is NQ and DQ. So I know it was different in there, but that's definitely the terms. I know that. And then some other terminology with it. Like I said, for a stack is first in, last out. And then for a queue, it's first in, first out. And if you wanted to start with last in instead of first in, the term for a stack would be last in, first out. And the term for a queue would be last in, last out. Any questions on that? And really just kind of all of the study guide at this point if you want me to go back to something. Okay, cool. So with that is the study guide. So got that down. Now for the actual lab this week, you will be implementing a stack in a queue. And it's due the 14th. So yeah, it's due this Sunday. It's a two-parter. Back here. So the first part of it, your implement for stacks and queues, is you're implementing ABS, which stands for AB stack. I don't know what the AB stands for. Array-based, sure. So you're implementing an array-based stack and an array-based queue. So the first thing you're doing is the stack, and the next thing you're doing is a queue. Both of them you'll be using an array. It'll be a template. You'll be using the big three like we talked about last week. You'll have to be throwing your own exceptions, doing deep copies. We talked about a lot of that last week. Stacks have that push pop behavior. Queues have that NQ DQ behavior we talked about. Got to implement your big three. You have to, because you'll be using dynamically allocated memory. Oh, you'll be implementing the concept of a scale factor. And the scale factor means when you multiply the capacity of your vector by, because when you allocate memory for your array in the heap, you allocate in a certain size. And so to start, you allocate whatever they tell you to, but if you reach the max of that, then you should double the size. And that's for just performance reasons, talks about it right here. And if you ever get to less than half of the size, then you should decrease it by 2. And again, that's just performance reasons, so you're not taking up as much memory. That times 2 value, that's not arbitrary. That's really, it's quite standard. You'll see a lot of 2s in mathematics just because binary is really fun. It could be something else though, and actually in the extra credit, you do change the scale factor. So you change the scale factor there. You have to get a perfect on the main assignment to do the extra credit. I think it talks about that there. Do not work on the extra credit until you got full points. If your standard lab doesn't have full points, you can't earn this extra credit. So if the extra credit is supposed to just be like an extra little thing. And it's a 1% towards your final course grade, not just this lab. So it is a pretty nice little bump, but still. Do not work on this until you have full credit on the actual lab itself. You'll have to implement all of these functions for both of these. It talks about the functions you'll need. And then the main in Zybooks calls all the stuff it needs to call. It's like it works just like we've talked about, like previous labs working. Do you get an extra week to do the extra credit? I think yes. I want to say yes, but let me go find it. The extra credit portion is due no later than 1 week after the original assignment due date. So yes, you get that 1 week extra credit. And then also for the extra credit, it's not code itself. The important part is the analysis and the graphs you make. So make sure you put a lot of time into this paper and the analysis you do. Like the code, honestly, I really don't care too much about your code. The extra credit is more focused on the write-up. That's what I'm really caring about, making sure you like put effort into this write-up and it's understandable and clear and you're using good terminology and all that good stuff. And your graphs are made well, not the code itself. Anything else here? Talked about stacks and queues. So yeah, last week was all the dynamic memory stuff. So go back and watch that recording. That should be up on YouTube. I assume all of you have the YouTube channel. If you don't, just message me and I can send that out again. But besides that, that's really all it is this week. The rest of the time is like any questions you might have. That's all the topics. So like this lab is a lot of content, but it's a lot of content based off of stuff we've talked about. So you kind of have to figure out how to do that. But if you have any questions, I'm here to help you with that. My pleasure, Alyssa. Playing sounds now. Here, I'm gonna stop the recording now too. My pleasure, Samuel. Stop the share. Stop recording. Yes.